Okay, so to backtrack, let me go to, so we're creating a diagram for a value parameter. So if int num equals 5 executes, then it gets its own address at some address ending in 4, and the value 5 is in there. Sum gets an address too. We've only created a variable, we did not give it a value, so there's a question mark here to denote that we don't know what the value is. And then sum equals sum of squares, num will execute. This num is used as a function parameter argument, and since it's a value or a copy parameter, a copy in memory is created for it. Okay, and then we want to see what this sum of squares function is. So I will go to while.cpp, and we will go here, right? So while sum equals 0, okay, we do it this. Okay, so we have sum and num. So num we've already denoted here, and now we also have to draw sum here, and then I think we initialize it to 0 in the function, right? So it's initialized to 0. So initially it is 0. I think in the homework assignment, like some students just copied my diagram into their assignment, and I had clearly stated that it was not the same code, right? So in the homework assignment, you only needed 3 addresses because in the function that I asked you all to use, there was no sum variable. So make sure you read the code, okay? Don't just copy it. I mean, most students, got an 8 or whatever, but the important thing is I want to make sure that you understand what's going on, right? So any questions so far here? What we've done? Again, 12 and 16 are occupied while the function is executing. So this one's right here while function executes. While function executes or runs, right? Which is milliseconds. Okay, so then we come in here, and there's a loop. So sum is changing. We're not worried about that. We're worried about what sum's value is here. Okay, we're not gonna, because then it'll make our diagram messy. So from our test cases, we know that if we use 5 for the function parameter argument, then sum would eventually be 55, but before that I think I had purposely modified num to 10. And which one do we modify? This num or this num right here? Yeah, so this is the function. Yes, the one at address 12, right? Ending in 12. Because we are working with the copy in here in this function, we are working with the copy. So with the copy that's in the function. So then this one will change to 10. And right before the function exits, or right before the function exits, then sum, this value is copied into the sum in main. So now we know that the value will be 55. And once the function exits, then our program no longer has any recognition or doesn't know that those variables exist. So now 12 and 16, and sometimes we do this, right, just to denote that our program will not reference them anymore. Those values are still there, 10 and 55, but they are available for our program to reuse. Yeah, well, I gotta, where's my, yeah, so I'm sure you all knew this already, right? It was a review, so do I have to review it? This is the same example I did last week. Yes, no, maybe so. Did you all get it? Okay, so before I messed up the diagram, there was a question mark here. This was 5, this was 0. So first thing that happens is num is changed from 5 to 10. Why? This statement right here, right? I mean, I do want to acknowledge that the value of sum is changing while it's looping, but we don't want to get into that detail. I mean, it'll make this messy, right? So we know that the final value will be 55. So after all this looping, sum will be 55, right? So then sum, and well, here we can see also that num is changing, but we're only interested in these three statements, right? Num equals 10 and return sum. Okay, so right before we say return sum, the value of sum is 55. And before the function exits, a copy is sent to the return variable sum equals, right? We said execute this function and send the return value into this variable. So that's why I have this line here, and 55's denoted there. And then when the function exits, and we want to mark our diagram with X's to denote that our program and the memory slots, that our program no longer references those regions of memory. And they are available, those 12 and 16, they are available to be reused by our program. Right, so this is the concept of a value parameter. So now is the time to ask questions. You'll definitely see this on the next quiz, questions regarding this concept. So if you have questions, now's the time. Yeah, all the variables are, all these guys are variables. Like, they're just variables. Even this right here is a variable. I mean, num's a variable. And even this one's a variable. They just have a fancy name, function parameter, but it is a variable. I think we missed some part of process. That's Julia, what do you mean? No, I picked up where I left off, but I'll review again, but it'll be brief. Okay, so this statement executes first, num equals 5, slots created at address 4. Sum is declared, but we do not give it a value, so there's a question mark initially, and it's an address 8. And num is used as a function parameter argument. It's a copy or a value parameter, so a copy is created and it has the value 5. Why? Because we are using num with the value 5 as a function parameter argument. So when 12 is created, a copy from 4 to 32 occurs. And then while our function's executing, we see that there's a sum variable there. So then we need a slot for that, and it's 0 because we declare a variable and assign the value 0 to it. And then I said I was going to skip what happens in the while loop to not make the diagram too messy. And we're interested in this statement, num equals 10, and then return sum. Like, what's the value of sum here at this statement? So when we say num equals 10, the num at address 12, because it's a copy, is modified, not the original one, which is at address 4. And then when we return sum, we know by then the value is 55, and then, well, before our function exits, and the value at address 16 is copied to 8, and that's 55 here. Once the function exits, we denote X's to all these lines and these values to show that those addresses aren't used anymore, and they are available for our program to use. Again, right? So, understood? Okay, that's good. Okay, so it'd be good if we could ask C++, like, well, is Mr. Gonzalez telling us, I mean, is the theory he's explaining to us correct, right? Is there a way that we can verify that num and sum get an address in memory? And if so, can we display it? And the answer, of course, is yes. So we come, let me see here, I think I can use, we can start here in main for now. So using cout, so let's see, num equals 5, cout, value of num. Okay, so we've seen that one plenty of times, but now we want to say address of the variable num. And if we use the ampersand symbol before the variable name, then C++ will display the address given to this variable. And let's go ahead and run this piece. So examples for value and ref, and then we run it. Some student asked me last week if this was in the book, like this. So this specific example is not in the book. Like, the book talks about reference parameters, and then they talk about the symbol, and then they tell you, they kind of like tell you if you use this, then you're referencing the address of the variable, and it's kind of like, wait a minute, what's going on here, right? So I always like to start by explaining what that symbol means, right? So we say here value of num is 5. The address of num is, notice here, gives us an address in hexadecimal, right? So that's good. Like, we know like where we know the address of this variable, which means that maybe we can use it for something useful. Yes. So for what? There's a concept in C++ known as a reference, and in C# and I think in Java, and then Python also has reference function parameters, but they are only live or in action if you are passing an object or a class as a parameter. And I'll explain like what all that stuff means, okay? But first, Right, so a reference variable can clone an existing variable. So we have the requirement here, we have an existing variable, num. So if we say I want to create a reference to an integer, and this is how you denote that, int and then ampersand, and we give it a name, num ref, and then we say num. Okay, so let me come here and maybe delete this, right, so that it can make sense. So we have num equals 5, and we know that that gets some address, and maybe we can use this one. We'll say FFOC, okay? So here we'll say FFOC. We won't write the whole address. So. Okay, so, and then we say a reference to an integer, num ref equals num. So the question is, like, when this happens, like this guy get its own address here, and then it acts as a clone, or is it like a real clone, and then like it's actually like an imposter, right, or a clone? And the answer is it gets a reference to the address of num, which means what? Let's come back to the code. So what does that mean? Like from this diagram, what can we say about num ref in relation to num? I mean, we know it's a clone, but like, can we? So Adrian, yeah. So they're pointing to the same address space. Evan, we'll change to its own variable. Yeah, so Evan's asking a question, and let's find out, right? So the question is, like, is it like a clone, and what can it do? Like, can it read the data? Can it change the data? And can it? And if it can change the data, I mean, is that safe? So let's go into that. So yeah, so Adrian, this is some special variable that probably gets its own address, but it's a clone. So I've tried to go in there and like get the address of this guy, but it's a clone. So I'm sure somewhere behind the compiler there's magic going on, but for now this is how we denote it, and it doesn't get its own address on the stack. Okay, so but let's see what happens, right? So we come here, and then let's copy this code, and then we'll just modify, like we'll say num ref here, num ref here, num ref here, num ref here, and then we'll go ahead and add another new line character here. So we created a reference variable, meaning a clone to an existing variable, and then we want to query it. So we want to say, okay, what's your value? I mean, what value are you pointing to? And then what's your address? Like, do you get your own address? Are you pointing to another address? What's going on here, right? So let's go ahead and execute this program. Okay, so value of num5, address FF008, value of numRef5, address of numRef. So right, so you see, like it's kind of like an evil twin or something, right? A clone, so an imposter. So the question is, now we can read, right? We know that, like we can read the num value. So if we can read, then let's see if we can change, right? Can we indirectly modify the num variable? And then we can copy at least this statement here. and then we'll add a new line there. So let's go ahead and execute this program and see what happens. Maybe see if num, right? We're more interested in num, not in ref. Num ref. So this is what we're actually after. And let's go ahead and run it. So the value of num is 5. The address FF08. That's okay. What we're interested in is this statement right here in line 18. So we say num ref equals 10, and let's see what the value of num is. So now we can modify the variable. Is that related to ASCII2? No. So questions here? Yeah, so what's the purpose of cloning a variable? Okay, hold on. So we know that. So if you all can answer this question. So if from here, and so we have a value parameter. This is a diagram, and we create a copy. We create a copy of this guy, num equals 5. If we use a reference variable, meaning we point to the address of num, then in the function, what can we do to num? When you look at this diagram and then this example that I just created. What was I able to do here? We save memory, yes, and we can modify it, right? So when do we save memory? Like if we're using integers, let me come back over here. Like if we're using integers as, oops, not what I wanted to see here. If we're using integers on the stack and we create copies, I mean, C++ is so fast, even C# and Java, right? That, I mean, using simple types like integer, char, boolean, double, long, right? Long, double, whatever. It doesn't consume a lot of resources, but yeah, so yeah, Adrian's correct, right? So it has something to do with memory. What if we're using a list of objects? Remember, a class can have variables inside. So what if that class has 5 variables and we have 10,000 objects or 100,000 objects in the list? Then there's no need to create a copy of the list. We can use a reference variable, and I'll provide an example right now to do that. And that way, when anytime our program uses that list, we don't have to create a copy of that list each time. Instead, we are just pointing to the original location of that list, which optimizes our program and consumes less memory, as Adrian's stating in the chat. But as Irvin also stated, we can modify the list. And what if? So that's kind of dangerous, right? Because number one, as a developer, you should never trust yourself. So we should never say like, no, I'm not gonna mess it up, because guess what? We will mess it up. That's why we're doing writing test cases. But when we get into situations like this, and the question will become, how can we protect ourselves, right? So let me ask one more time if there's questions with this diagram, and if there's not, then we'll go ahead and create an example with a function reference variable and diagram it, and then we'll discuss what issues we can get into and how we can get around them. Okay, so a reference variable. Let me go ahead and erase this stuff. I gotta use my pen, right? So delete this, and then okay, and then let me recreate this right here. And I think this was num1, num2. Oops, kind of small. And we don't need this piece yet. Okay. Okay, so that function we've never seen, right? We've never seen the function pass by val and ref, but let's go ahead and create it. So we come here, value, and we create a function, a void function. We call it pass by val and ref. So we know how a value parameter looks like. It simply looks like this. And then we know what a reference looks like, and well, that's how a function reference variable looks like, or parameter looks like, right? Int. So I want a reference to an integer, num2. Okay, so this one will create a copy. This one will not create a copy. We will be pointing to the variable that is used in the code that calls this function, and we'll write that code right now, and then we will diagram it. So we go to value ref.cpp, and the function really doesn't do much. All we do is assign some values to it. So num1 equals 20, num2 equals 50. And that's all this guy does. So nothing magical here, but we want to see the difference between a value, a function value parameter, and a function reference parameter. Okay, so let's come back to the diagram. And int num equals 0. Okay, so we should know how to diagram this one. 0. And then we have num2 equals 0. At address 4 and 8. And then we have a function call, pass by val and ref, and that's the function we created. So we know that a value parameter, which is the case for num1, and it looks messy. Let me fix this. Oops. Pass by val and ref, num1, num2. Okay, so we know what happens to num1. What happens? It's a value parameter. I'm still waiting. Where is num1 in the stack memory? So it is num1 is here, but when we execute this function, what happens to num1? Yes, so it has its own address space, and it'll be the next available slot, which is 12. So right here, and what value will it have? A copy of it is made, which means it gets a value at y4, which is 0. I don't know why it is 0, right? But it gets the value from y4. And now the question is, what happens to num2? So we know num2 gets its address space, and then num2 here is that special type of reference parameter that I diagrammed for you all here. So what happens when we use it as a function parameter? Will it point to an address, or will it get its new address and get a copy? What's going to happen? No new address. So maybe we shouldn't let Julia do all the answering, right? So can someone tell? I mean, she partially answered it. So no new address. So which one? I guess 33% chance, right? So which one will it point to? Oh, okay, I see that Irvin said that it would point to y8, and yes, that is correct, right? So then this one points to y8, which means that it can read it, and according to the example we did, it can also modify it. So there's a diagram here. Let's not fill in anything else, and let's create a test case for this to see what happens, right? So let me see, 4, okay, module 4. I don't see how num1 is different from num2 in this case. It's right here in the way we created the function code. You see, like, this is num1 and then this is num2. You see int here, and then you see int right here with a reference. So that's the difference. So yeah, you're not going to see the reference over here. You're going to see it in the way the function headers created. Okay, so test case, value ref is included, and then we can say let's create a test case. Like in these topics, I purposely go slow and I make sure that I ask 100 times if there's questions, because you have to understand this material. Otherwise, like, you're going to struggle for the rest of the semester. So test value and reference parameters. Okay, so we have a require assertion, and we say pass by Val and Ref, but we need variables. Like in the example here, we need variables num1 and num2, so let's create them here. So we have int num1 equals 0, num2 is also equals 0, and then num1 is the first parameter, num2 is the second one. So we have to call the function first, and This is incorrect. So we have to call the function first, and then we create our assertions. Okay, so we call the function, and then we say, okay, I expect that num1 equals what? Knowing what we know about value and reference parameters. Like, will num1 change or not? That's what we're after here. And then what are we expecting for num2? So num1 would have what value? Like, let me show you the code again. So num1 is a value parameter, num2 is a reference parameter, num1 in our test case gets the value 0, num2 also gets the value 0. In our function we change num1 to 20, and then we change num2 to 50. Okay, so Ilario, num1 does not change, num2 does change. So we go back to our test case. So then, according to Ilario, this one will be 0, and then this one will be 50. And then we can execute our test case to see if that's the case or not. So let me look for the test case. Run. Okay, it's building. And linking. So green we know is good, up arrow, space, dash S, enter. So we are interested in test value and reference parameters. So num1 is still 0, num2 changed, right? So it is 50. So we go back to our diagram to diagram this. So we modified in the function, we say that num1 is equal to 20. So if num1 is equal to 20 and our test case passed, then that means that we changed a copy. We didn't change this one, we changed this one. So this one got the value 20. And then we said num2 equals 50. We set that in the function, but num2 is a reference parameter. So then we changed the original variable. And then our function exits. So when our function exits, we no longer reference the copy, and we no longer get a reference to an existing variable. This value is still alive in our program. This one's, our program has no knowledge of them anymore. Average 12. Questions? Yeah, because we didn't change this one, right? So this in num1 doesn't get modified. So in the test case, we're expecting it to be 0. No, again, what happens is in the function variables, right? So this is a value parameter int num1, and then here we say I want a reference to int num2. Right here is the key, a reference. In our test case, we just declare the variables like we always declare variables. Yeah. Yeah. Yeah, so and that's what I drew here, right? This y12 was pointing to num1. Once the function exits, our program no longer points to that address, and that address can be reused in our program. So questions here? Like any questions of understanding or any questions of like trusting developers to do the right thing? It is the same to type. Why do students always ask me those questions? Just stick to what the example I gave you. I don't know. I mean, I'm not a language lawyer. Like, if I don't know, I usually try it and compile. And then if it doesn't work, I'm like, oh, it doesn't work. Even if it works, then you still have to write test cases to make sure that the code's going to do what you think it's going to do, right? And that was for Irving. He wants to know, like, if we put the ampersand over here, I think you get an error, but I'm not sure. I haven't tried it. Like, put the ampersand here or put the ampersand here. Put it here. Okay. I mean, you all trust other developers to do the right thing? Like, if this is a payroll program and you pass the number of hours by reference, you trust them that they're not going to modify your data? And if you don't trust them, I mean, what can we do to keep them from modifying our data? Hey, I'll cover one of your ears like this so you don't talk like I do. So how often do we use reference parameter encoding? So if we're working with integers, like a simple types, like an integer, char, double, and other simple types that are not a list. In C++, a list is a vector. At least that's the most popular one, and that's the one students get introduced to. So if we're using simple types, then we can use value parameters. And can I opt to not return a variable and modify variables like this? Yeah, but I mean, why not just return a variable? Because then, like, another developer in the future might not know what you were thinking, and then, you know, they can introduce bugs. So if you are using simple types, use value parameters. If you're using list or a vector, and that's a list in C++, then we will need to use reference, right? Because a vector is a list, and we don't want to be creating copies of lists, especially if that list is called a lot of times in our programs. We don't want to create copies. Let's just go ahead and reference its original location and read the values. But that opens us up for having those values modified. So how can we get around that is the question. Like, do you trust other developers to do the right thing? Like, if this is it's like a financial application, stock application. No, like we shouldn't even trust ourselves with this kind of code, because I mean, if we leave ourselves a chance to make a mistake, we will make a mistake. So we can make a reference parameter read-only. Say if we have a vector of objects of employee payroll, and all we want to do is like print the paycheck or use that list to create the automatic deposit in the bank, then we want to give developer access to the list, the original list, not a copy, but in read-only mode. So when we were talking about variables a couple of weeks ago in one of the assignments, we talked about the const keyword, constant. So we can create a const reference parameter. And in creating a const reference parameter, we can eliminate mistakes that we can make or other developers can make in the future. So we come back to the code here. And then I'll show you, hold on. Okay, so const reference, right? So we come to value ref.h and we have this instructions here, write prototype for, so void pass by const ref, and we'll say num3 just so that we can have like num1, num2, num3, right? It doesn't really matter, but just makes our example in the diagram make sense. So we copy the header, go to the CPP file, and actually I said const reference, right? So const and a const reference to an integer, and we have to make sure that the signatures match. So now we have a const reference to an integer. And let's go to the diagram. What is this? How does this help us? So we have another variable here, int num3, give it some value. So it'll pick up the next available free space, and that one, well, it's the one we had already used, but this one's available to our program again. And the value will be 5. And then we say pass, what's the name of that function? By const ref, okay. Pass by const ref num3. And we use this variable right here as a function parameter, and it's a const reference parameter. The keyword here is reference first. So if it's a reference, we know that it points to an existing variable, in this case, this one right here. But the function has a direct access to the address and to the value, but it can only read it. Why? Because we use the keyword const. So if this was like a financial application or a stock application, we want to be careful with how we use our data, then we can say, I don't know what I'm doing, and I'll pay myself $100,000, right? So notice right away, like it tells us right here, like it gives some, well, actually at the bottom right here, right? So right here, expression must be a modifiable L value. I mean, fancy for num3 or this function parameter. It's a reference, but it is read only. It's constant, so it cannot be modified. So we can only display it or use it for some calculation, right? Whatever, but we can't override it. And that's how we can protect our program. And we'll see when we get into classes how we can use this const keyword to protect the integrity of our data that lives in classes. Question here. Yeah, so I was just, I guess I didn't do a good job in explaining, right? So if we have a list of payroll, a list of stocks, and we don't want developers to accidentally modify it, right? Like if it's a list of the payroll for the employee, maybe we want to send it, or it's available for somebody to create the automatic deposits to the bank, then we don't want them to modify the values. We don't, like, we shouldn't trust them. Likewise, if it's a stock app, right? Like, we only make reference when we know that the data needs to be changed. Any other time, always const. And once we get into classes, you'll see like what we are talking about. But does that make sense, right? Like, we shouldn't trust not even ourselves. Right? I mean, that's if we want to stay employed, right? So that's a value parameter, reference parameter, and then a const reference parameter. And if you took notes, and if not, then you can go back to the lecture and just jump to the diagrams and draw them or have them, because you will see this from now to the end of the semester, and you'll see it in data structures too. So you have to make sure that you understand the concept of value, reference, and const reference parameters. Any other questions? So make sure you understand this material, because they'll greet you with a quiz the next class, right? So if you didn't completely understand it, the video should be up by tonight at midnight. You can go revisit it. Okay, so we have function overloading, but I wanted to jump back to this static variables, and I wanted to go ahead and create a simple example of that one just to show you how they work. So let's create an example here. So value static example, and then we go to value ref, and okay, and well, I guess I'll have to introduce IOStream here. It gives me access to cout, stat cout. So then I just want to say display the value. A simple function, right? So it creates a variable, and then we are going to increment it. So what is static is the question. Like, what is static? It means that the value will persist, or will be, this variable will be alive or live as long as our program runs. Notice I said program, not function. So as long as our program runs, count will be live, and it'll keep its current value. And let me go to the diagram. So it's not stored on the stack. It's stored in its special memory region known as static memory. So let's see what happens, right? So there's no test case. We don't return a value, so there's no test case. We'll just come here, and for now I will mute, comment this stuff out, and we have to include value ref, and then I say static example 3 times, and we execute this program. So this one right here, run in terminal. So notice that we called the function 3 times, and then it's the first time the value was 1, the second time we called it value is 2, and the third time the value is 3. But a key here is that this variable persists or lives through the lifetime of the main program. So as long as the program's running, the value will persist. Once the program runs and it doesn't exist anymore, and if we run it again, it starts again, right? So 1, 2, 3. If you wanted a counter that would live after the program dies or is exited, then you would have to save it to the value to a file or to a database, right? And then when the program opens, you would have to read that value, and then as the value changes, you would want to be sending the change to the file or to the database. That way we could count, as high as we wanted. Questions here? Okay, crystal clear. So next topic is function overloading, which is a concept where we can have the same function name as long as the function parameters are different. And this comes in handy because sometimes we may be able to perform whatever the function does, a calculation or processing or whatever, with some of the data, and if not all the data is given to us, then we may use like default values, right? So how does it work? I don't remember what example I used for the other class, but I don't want to make it too complicated. So maybe we what do we do? Get area? Well, it won't make sense. And pass by Val and Ref. Well, even if it doesn't make sense, well, let's use this one instead, right? So we say, no, this one's probably easier. Okay, so we have pass by Val and Ref, and I'll purposely remove one parameter. I have to write the function code in the CPP, right? So I have function code for this one. I don't have function code for this one, so I can go to the CPP, and I'll just keep it simple, right? So here I will say open close curly brace, and I'll just say what we were doing over there, right? Num1 equals 20. And I can come to main.cpp, and I can say pass by Val and Ref, and then notice the IntelliSense, the code helper, right here is telling us that there's one of two what, right? So notice here it's saying that we can use this function with an integer, and if we click here, we can also use this function with an integer and value integer or a reference parameter, and we can say this, right? So just to show you that it does work. I don't need this guy anymore for now. We need to create some variables here. Pass by Val and Ref, so num1, num2. And notice that we're good. And that's how we can use the concept of function overloading. depending on the use case, right? Like for example, like if we're doing a payroll application and we have the hourly rate and they don't include the hourly rate in the parameter, well, maybe that means we default to a standard hourly rate, I don't know, $10 an hour or something. And anytime we have the hourly rate, then we don't use the $10 an hour, we use whatever value is given to us. So, and it applies to different, not just payroll, right? Any use case. So questions here for pass by val and ref overloaded or function overloading. Okay, so what did we learn today, right? So if you learned something today, please remember or know the difference between a value parameter and a reference parameter. If it's still hazy for you, go back and watch the video. You'll do yourself a big favor and it'll make the class a lot easier for you as we progress into more difficult concepts. Again, a value parameter means that a copy is created when a variable is used as a function parameter argument, right? So we don't work with this variable in the function, we work with a copy, meaning this variable is safe, we can't modify it. We learned about the special clone variable or the reference variable where we can actually clone a variable and we can read it and we can write it. And that allows us to use the concept of a function reference parameter. And what is a function reference parameter? It means that if we have a reference parameter as num2, and what is a reference parameter or how does it look like? It looks like this. It's the data type followed by an ampersand, and this means this is a reference parameter. And when used in code, num2 is used as a function argument. Num2 can be modified in the function code, which is good in some cases, but in most cases it's just not good. And if we know it's not good, then we always want to revert to const reference parameters. So const reference parameter, meaning yes, you have access to the original memory location of num3, the original memory location, but only read-only. You will not be able to modify it. You can call it whatever you want, but just remember when you go and talk to other programmers, you know, they might be like, what? So it's usually in the industry, even in Java and C#, they're called reference parameters. And it's pass by value or pass by reference. And they may or may not understand you if you use like overriding. They'll be like, what? Right, so. Okay, so that's all I have for today. There'll be a quiz at the beginning of class on Wednesday. I'll post the announcement tonight. And we'll get into talking about strings more. And then vectors, right? So we'll have a lecture over strings and vectors. So usually I can probably combine those into one lecture, right? Because I just want to make sure students understand that what a string is and how it works differently from integers and chars and booleans. And then we'll get into list, which is a vector. Like I'll introduce vectors. Okay, so if there's no questions and classes, that's all I have for today. I mean, I'll be here to answer questions that students may have, but for now, if there's no questions, then class is dismissed.